Hey everyone, let's see about finishing up those last stations. So, we did come in. Okay, a car is initially moving at 88 feet per second and has a constant deceleration and stops in a distance of 200 feet. Okay, so this is 88 feet per second, and this is velocity equals 0. And so, constant deceleration. And a stopping distance of 200 feet. Okay, this is not 200 because this is time, and this is feet per second. So, seconds. Since we have a constant deceleration, there's 0, and stops in a distance of 200 feet. 200, 88, t. Right? Because this is feet per second times seconds. The seconds cancel on the feet. Okay, so let's divide both sides by 88. 200 divided by 88. And we get 2.2727, and so on. Okay, sketch velocity graph. There it is. That's part A. Part B, find the time it takes to stop. B, find the car's deceleration, and don't forget to include units. Oh, well, so we've got this ordered pair. I feel like this 200 over 88 is 50 over 22, or 25 over 11. 25 over 11 seconds. All right, so part C, car's deceleration. Well, that's the slope of this line. So let's write the equation of that line. 88 minus 0 over 0 minus 25 over 11. That's going to be 88 over negative 25 over 11. So negative 25 over 11. It really is. And then I flip and multiply. And so that's going to be 88 times 11 over 25. And this is a negative number. That seems big. 88 times 11 divided by 25 is negative 38.72. This is feet per second. And these are seconds on the bottom. Yeah. So those are my units. Okay, that's station 11. That didn't take very long. How about station 12? Station, find the area of the region bounded by y equals cube root of x and y equals x. Okay, so here's what happens with this problem. People do this, and they forget to do that. These two are the same. Now, I can say because both of these are odd functions, they have origin symmetry. And so if I find that area using top minus bottom, I could just double it to get the total area. We know these points of intersection are 1, 1, and negative 1, negative 1. And you can figure that out by setting this equation equal to that and solving for x, or graphing on your calculator and finding those points of intersection. I knew it because, well, I know these reference graphs both pass through that point. Okay, and we're supposed to find the total area of the region. That's cube root. All right, so then I want the integral from 0 to 1 of top minus bottom. X to the 1/3 minus x dx. Okay, it's going to be x to the 4/3 with a 3/4 in front. This is x squared over 2 from 0 to 1. Plugging in 0 doesn't get me anything here. Plugging in a 1, 3/4 minus 1/2. So this area is 1/4. And this area, top minus bottom, will also be 1/4. Because here we're doing the integral from -1 to 0 of x minus x to the 1/3. Okay, and so when I do my antiderivative here, I have x squared over 2 minus 3/4 x to the 4/3, and I'm evaluating that from -1 to 0. I plug in my 0, 0 minus, I plug in my -1. Here I have 1/2 -1 raised to an even power. Oh, positive. So that's going to be 1 times -3/4 minus 3/4. And here we end up with -1/4 times a negative. So I get positive 1/4. There it is. And so the total distance, the total area would be 1/4 plus 1/4, or 1/2 is the total area. Okay. Second question, we want the area of the region bounded by x equals y squared minus 2 and x equals y. Okay, so what does that look like? There's x equals y squared minus 2. -2, 0, I believe is the answer. Let's try. If we plug a -2 in here, -2 times -2 is, oh, that's 4. Oh. The y value here is 0, so that's -2. There we go. -2, 0. Okay, and if I plug in 0 for x, I get √2, and I get -2. Fabulous. And we've got the line y equals x. So we're looking at this situation, and I want the area bounded by these two curves. So I'm looking for this. But, no, really, I do not want to do top minus bottom. Because while top minus bottom here works, over here, top minus bottom is the same curve. And that doesn't really sound like a lot of fun for me. So I'm thinking about doing right minus left. I do need to know where these points of intersection are. My guess is, yeah, I have my guess. So I'm going to set these equal to each other. Y squared minus 2 equals 1. Y squared minus y minus 2 equals 0. Y minus 2. Y plus 1. And I get y equals 2 or -1. Well, here's y equals 2. And here's y equals -1. And since x equals y, that's my x value as well. Okay, so integral, well, my integral will be right minus left. So I'm going to have y minus y squared minus 2 dy. We're going from this y value to this y value. Okay, so that's the integral of -y squared plus y plus 2 dy from -1 to 2. That's going to be -y to the 3rd over 3 plus y squared over 2 plus 2y from -1 to 2. If I plug a 2 in there, I have -8/3 plus 4 over 2 is 2 plus 4. And we want to subtract, plugging in that -1. -1/3 times negative is +1/3. Negative times negative is positive 1/2, but a negative in here is -2. Okay. Yeah, 4 divided by 2 is 2. And what's that one? That's supposed to be -8/3. That's an 8. Okay. So it's going to be -9/3, or 3, plus 6 minus plus 2 minus 1/2 is plus 1/2, or plus 3/2. So 18/2 and 3/2 is 21/2. 21/2 is my area here for station number 12. And then finally, and I don't know if there are any of these on the test. My suspicion is that there are not. Station 13 is just to keep you practicing your integrals. You should be comfortable with all of these. And if you're not, guess what? You're going to blow some of the basics, including a chunk of multiple choice could be lost here. So, A. Integral of 1 over x minus 2 dx. You could do this as a u sub if you want, where u equals x minus 2, but you should end up with ln x minus 2, don't forget the plus c. Remember, we can check our integration by taking the derivative. The derivative of ln of stuff is going to be 1 over stuff times the derivative of stuff. Well, the derivative of that is 1, and so do I have? Yes, 1 over stuff. Okay, B says 1 over x minus 2 squared dx. Well, that's the same as x minus 2 to the -2 dx. So the antiderivative here, x minus 2 to the -1, because I added 1 there. But if I take the derivative of this and bring down that -1, subtract 1 to make -2, I don't see a negative here. So there must be something present in the original function. So when I bring down that negative times negative becomes that positive. Don't forget the plus c. Okay. Now we've got the integral of x over x squared minus 1 dx. This is definitely a u sub. I see a function, and I see most of the derivative of that function. If u equals x squared minus 1, du over 2 is 2x dx. I see the x dx, so let's just get rid of that 2. du, yeah, that over 2 is this 2. Okay, so then how do I rewrite this? Well, I can rewrite this as the integral 1 over u times du over 2, or 1/2 1 over u du. So in this situation, our antiderivative would be 1/2 ln of u plus c, and our u was x squared minus 1. So 1/2 ln x squared minus 1 plus c. Good. So that's c. What about d? Well, d is partial fraction decomposition. We've got 1 over x squared minus 1 equals a over x minus 1 and b over x plus 1. So we get 1 equals a x plus 1 plus b x minus 1. If we make x equal to 1, all this goes away. And we get 1 equals 2a. And so a equals 1/2. If we make x equal to -1, that goes away. If -2b equals 1. And so we know b is -1/2. So this thing that I couldn't integrate can become these two things, which I can integrate. Okay, so let's do some integrating here. Pull out that 1/2. 1 over x minus 1 minus 1 over x plus 1 dx. So the antiderivative of this is ln of x minus 1, and the antiderivative of this is ln x plus 1. Don't forget you have 1/2 here, and don't forget there's a plus c. We could, of course, condense this. 2 logs join with subtraction. I can write 1 log x minus 1, x plus 1, to the 1, and we've got that 1/2 plus c. You could always kick that up there too. And so this will be fine. I wouldn't leave it here. Okay, but yeah, partial fraction decomposition. That was exciting. Don't forget your math. Integral 1 over x squared plus 9 dx. Well, seeing that plus always makes me think, wow, this is so close to inverse 10. If only this was a 1. So divide by 9 to make that a 1. But that means simultaneously I have to multiply in the denominator by 9. So now I've got 1/9 integral 1 over x squared over 9 plus 1. Excellent. So my u is x over 3, because u squared would then be x squared over 9. Don't forget, you want du is 1/3 dx, or 3 du equals dx. So that can go in there, and this can go in here. I get then 1/9 times the integral of 1 over x over 3, so that's right there. U squared plus 1 and 3 du. Well, I'm going to pull that constant out with that 1/9. So I'll have 3/9 or 1/3. Okay, so we've got 1/3 integral 1 over u squared plus 1 du. And that's going to be 1/3 tangent inverse of u plus c. Now we started with x's, so we have to end with x's. So u is equal to x over 3, so that's what I'm putting in. Okay, and then the last one. It's funny because when we first talked about this problem number 6, no, difficulty, and now so many hands going up in class. Mr. Cook, I don't know how to take the integral of an absolute value. And what I've said to you every time is that, if you have an absolute value function, yeah, I also don't know how to do that unless we turn this into a piecewise function, where it behaves like y equals x for x values greater than 0, and behaves like y equals negative x for x values less than or equal to 0. And no, this equal to could easily go there. It's completely arbitrary. Okay, but I don't want to do that here. Instead of finding that piecewise function, when I'm thinking about -2 to 3 of absolute x minus 1 dx, I'm thinking about this graph which is shifted right 1, and integrating from -2 to positive 3. I think I actually flipped these because I think this distance is 2, this distance is 3. This should have the higher height than over here. So let's see if we can fix that, at least visually. There we go. And so, yeah, I get 2 triangles. And I would like to appeal to the geometry of the situation rather than trying to write a piecewise function, which I could then integrate. So this triangle has a base of 3 and a height of, if I plug a -2 in here, -2 minus 1 is -3, absolute value of -3 is 3. Okay, so I know the height is 3. Excellent. Plus, what about over here? Well, 1/2. 2. 3 minus 1 is 2 times, what's the height at 3? 3 minus 2 is 1, is 2. Absolute value of 2 is 2. All right, so I get 9/2 plus 4/2 is 13/2. And that's the value of that integral. Don't forget to appeal to the geometry of the situation. All right, well, that's all the problems for this video, and I look forward to working with you in the next video. Take care, everybody.